I do need to teach today. So we need to talk about something called slope fields. Where there's the next little unit is something called differential equations. And it's basically, how do you find, if I give you dy dx equals something, how do you figure out what y is? I mean, if you think about it, that's what an integral is. If I tell you dy dx equals x squared, you think, well, that's easy. If our derivative is equal to x squared, then y is going to equal, x cubed over 3 plus some constant. That's effectively what I've been making you do the past month or so, right? But what do you do if it's dy dx equals x plus y? Like, what if your derivative equals something weird, right? What do you do? Like, how do you find, like, your goal is, I want to know what y is. And sometimes you can't solve for y, right? Sometimes you can't come up with, I don't know what y is. What a slope field does is gives us a way to find a picture of what y is, right? And so that's what we're doing today. It's like, this is what happens when you can't figure out what y is, but can we find a picture of it? And today we're going to talk about how do you find a picture, right, of it. And we do that with this thing called slope fields. Now, this is aptly named because this is literally a field of slopes. Of course, what the heck does that mean? Right? All right. So what I want everyone to do, right, so I'm scrolling down, is I'm going to start. So this is an example of this is a differential equation, right? Anytime it has derivative equals something, that's a differential equation. There's a derivative and its equation, differential equation. And what we are going to do is construct a slope field. And this is incredibly tedious, okay? And here's how you do it. First, you have your nifty little formula. Everybody see our nifty little formula? Right? Derivative equals this. Now remember, derivative is slope. So this is a formula for slope. And so it says my slopes are equal to x squared. And here's what we do. We start off, and here's what I always do, is we literally have to find what's our slope at all of these points. Yay. So how do we do it? Well, here, let me pick, I always start with the origin. Okay. So when I plug in 0, 0, this is my x, this is my y. When I plug in, actually the official notation for this is dy dx evaluated at the coordinate 0, 0. I'm not going to write this down for everything because, grief, I would do forever. Plug in 0 for x and 0 for y. Well, if you plug in 0 for x and 0 for y, what is your slope going to be? Well, if you have 0 for x, you get 0 squared, and it doesn't even have a y, so you don't care, right? So you're okay that's got a slope of 0, right? Well, rather than write this notation down, dy dx, what I'm going to do, kind of shorthand, I'm going to talk about, well, what about 0, 1? What's our slope going to be for that?
1.
What's your x?
Oh, 0. So
And
0.
you don't even realize, we're okay with our slope is 0?
Yeah.
Okay. And if I'm at 0, 2, what's my slope going to be?
0.
0, right? Do we get the pattern? Right? So pretty much all of these, like 0, -1, that's a 0, 0, -2, that's a 0. And here's what that means. And if you've got, like I've got stuff writing on paper, what we have to do is we have to draw a slope of 0. Are we okay? A slope of 0 is this flat line. And it looks like this. So at 0, 0, I'm going to draw a slope of 0. 0, 1, I'm going to draw a slope of 0. 0, 2, I draw also 0, 0. So is everybody drawing those little bitty slopes? Right? Do you understand how I got them?
I can't really see.
Oh, sorry, I'm in the way. So, what we do is, here, erase this and probably write in a darker ink. So here's our formula. It's dy dx is equal to x squared. And we pick every single coordinate. We plug this in for x and plug this in for y. to determine what our slope is? Well, there's no y, so we don't care, right? We're basically just looking at our x values. Are we okay with this? All right. Well, we haven't finished our field yet, have we? Right? I got a whole bunch of dots I got to figure out. It gets repetitive, so I'm not going to do much. Let's start with here. Let's start with the point. What if I do 1, 0? What's my slope going to be?
1.
1, right? And if I put 1, 1, 1, 2, 1, negative 1, 1, negative 2, can we see these are all going to give me 1?
So it doesn't depend on the y value.
Yeah, because there's no y there. Don't worry, I have more examples that have a y, but this is the first example, so we good. And does everybody know what a slope of 1 looks like? It's that 45-degree angle. So we get to draw a 45-degree angle here, here, and here, and here, and here. We okay? All right, well, let's try some other ones. Well, what about negative 1, 0? What's that slope going to be?
1 stuff.
1. Okay, can I go ahead and say that all of these are going to be 1? Negative 1, 0 has a slope of 1. Negative 1, 1 has a slope of 1. Negative 1, 2 has a slope of 1. All right? Because if your x value, all of these have the same x value, right?
Right.
So it doesn't matter what the y is. So they're all going to be the same. All right, now we erase. And so now let's figure out, well, what happens at 2, 0? What's my slope going to be? 4. Okay. Are we okay at 2, negative 1? The slope's 4, right? Pretty much 2 anything, the slope's 4. And what does the slope of 4 look like? And you don't have to be perfect, right? Is it steeper or shallower than the slope of 1?
Steeper.
Steeper. Are we okay? The slope of 4 is steeper. And so when we draw it, we don't have to be perfect, right? We just have to make sure, in theory, a slope of 4 should be like up 4 over 1, right? So it's kind of steep. Just make sure it's steeper than the slope of 1. Okay? And so I'm going to draw my... Okay with that? And then here, let's talk about if I have a slope of negative 2. If I have negative 2, 0, negative 2, 1. Okay, what's that slope going to be?
4.
4. Okay, yay. Okay. So I end up with the same thing, and so we end up with basically the same slope over here. Just make sure it's steeper. Everybody have that? Okay.
Thanks.
Okay. All right. We have just constructed our first slope field. Yay! Right? And as ridiculous as this sounds, sometimes there's an AP question where they give you a differential equation and they say construct a slope field. It's incredibly tedious, right? Right? So are we okay with it? So our slope field, they usually don't make you plot this many dots. When you construct a slope field, the things that you care about slopes of 0, right? And you care about slopes of 1 or negative 1. We don't have a negative 1 here. And you care about vertical slopes. We don't have that here, but I'll talk about it later, right? And the other stuff in the middle, you just make sure we get, it's steeper or shallower based on what you have. Okay, so far so good? Okay, now, what good is a slope field, right? The goal of a slope field is to create a picture of y. All right? Like the goal is, anytime you're given a differential equation, the big picture is, okay, fine, the derivative of y, they give me a formula for the derivative of y. I want to know what is y? I don't care about the derivative. I want to know what is y. Right? And you've been programmed for the past, however long this semester, okay, we can figure out what y is. If I say dy equals something, you can take the integral and you know exactly what y is. Right? But there's going to be cases in the near future, like the next example, where you can't figure out exactly what y is, but can we create a picture, right? And so if we construct a slope field, we can create a picture, and here's how you do that, right? First, you need a dot, right? And so I'm going to pick my dot, and I can put it, they'll tell me where to put it. They'll usually, like the way they'll tell me where to do it is they can say that y of 0 is equal to 1. And what they're telling you is, okay, put a dot at 0, 1. Right? It's got an official name, it's called your initial condition, but we put a dot. Now here's how I want you to think about slopes, the slope field. I want you to think that all of these slopes are little arrows. Can everybody envision like there's little arrows? And I want you to think of this as wind. Like this is the way the wind's blowing. All right? Can everybody think of that for just a second? All right? I want to visual, like I want to animate math. Right? And it's hard to do this in a math because I want you to think of these arrows as wind, and so the wind is blowing. All right? Can you all envision that? And this wind is blowing up, this wind is blowing over, right? The wind's blowing all sorts of ways, right? And I want you to think of that dot as a ping pong ball in the wind. All right? And so if the wind's blowing the ping pong ball, right, whatever path the ping pong ball goes is what y is going to look like. So, see how this is blowing straight this way? So our ping pong ball is going to go right a little bit. And then this wind comes in. Like imagine all of these are like a bunch of fans pointing in that direction. And that poor little ping pong ball just gets pushed around. And so our little ping pong ball starts off here, it goes up, up, and then these start steeper and it goes up, up. And so we end up with a graph that looks something. See how it's pointing up? Right? Can you see that this could be and I'm not perfect, right? But you see how this could be the graph of the way the ping pong ball gets blown? Now let's imagine what the ping pong ball looks like going the other direction. Of course, imagine to go backwards. Like how would we get here? Well, I'm betting it probably looks something like this, right? Can you see how the ping pong ball would have been based on this slope field? This is how our ping pong ball would float.
Yeah.
Okay, and again, as silly as this is, there actually have been 2 cases of free response questions where they gave you a slope field and an initial condition and say, draw the graph. That was a question. That was a part of a free response question. So as ridiculous as it seems, like how could they ever ask a question? They have, twice. Where they give you a slope field, they give you initial condition or your dot. There's a lot of leeway, right? Because, how do you figure this part out? Like the flat one, okay, we got that. But the angles, like how do we do it when it's in the middle? And I probably messed it up here. Okay, did that make sense? Does everybody understand the purpose of a slope field, right? The purpose of a slope field is, right, if I can't figure out exactly what y is, can I create a picture of y, right? And to create a picture of y, you need a dot, which is our ping pong ball that gets blown around. Now, this is a very basic example, right? Because the reason it's because I didn't want something complicated the first time. Like this one we could solve. So if dy dx is equal to x squared, and actually I did mess up, it's probably closer to this, yeah. Well, if the derivative, so if y prime is equal to x squared, what's y going to equal? If the derivative is
X cubed over 3.
x cubed over 3. Ah, does this look like an x cubed graph?
Mm-hmm.
All right. See how this is a case where we could actually figure out exactly what y was as a function, but we represented it with a picture. All right. All right. Is everybody okay with the first example? So now, let's look at the second example. Oh, oops. Actually, so to get a really good slope field, just plotting it to those few points doesn't really matter. It doesn't help. Can you sort of see here you have more slopes, it makes it easier to draw the picture. Like if I started at, this is the same slope field, but done not at every integer value, but at many values, then you get this, then it's much easier to draw your curve graph if you have more slopes to deal with. Okay. All right. So, that was a very basic case, okay? Right? That was the entry because we could actually figure out what y is. This is more typical. So we have our, okay? So we have our differential equation. Sometimes it's dy dx equals stuff. Sometimes it's y prime equals stuff. And what I want everyone to do, right? I'm going to give you a few minutes because I need to take a roll. I want everyone to construct the slope field for this. And then I'm going to come back. And yeah. And actually, I'm going to give you some guidance. Find the values that give you 0. Like what coordinate would give me a 0 slope? The origin would. Okay, so 0, 0 would give me 0. What else? How about 1, negative 1? Does everybody see that? And what about negative 1, 1? Does everybody see those give you 0? When constructing a slope field, first find out where your slopes are 0, and then do that. All right, and now I want to go through how I do this. So to physically list out all these coordinates would be very tedious, wouldn't it? Because that's a ton. I mean, there are just a ton of coordinates to try to plug in. So if you can find out, like in my mind, I looked at it, where is y prime 0? And y prime is going to be 0 at the origin and anytime here and here. Does everybody see that that's going to give me a slope of 0? 1, negative 1. Oh, forgot that one. Okay. So we get our slopes of zeros. Right? So all of these are going to give me a slope of 0. The next thing I want to talk about is when do I get a slope of 1? Okay. And I get a slope of 1 when it's like 0, 1, 1, 0, right? Okay. These have a slope of 1. Let's see, 2, negative 1. Now just plot some of those and see where we are. Okay, at 0, 1, this is a slope of 1. At 1, 0, this is a slope of 1. At 2, negative 1, this is a slope of 1. Oh, look, there's a slope of 1. There's a slope of 1. Do you see how if you start looking for where do I have slopes of 1, we get that. Next, I'm interested in, okay, well, where do I have a slope of negative 1? And that's going to be, let's see, negative 1, 0, 0, negative 1, negative 2, 1. Okay. So let's see, slope of negative 1 is going downhill, so let's see, negative 1, 0, that's here. 0, negative 1, that's here. Negative 2, 1, that's here. Again, I know this is just the second time constructing a slope field, but do you see how if you can figure out where stuff's 1 and negative 1, then it makes it easier? And I don't know if you noticed, particularly in this example, but the diagonals seem to have a pattern, don't they? See how everything on this diagonal is a negative 1, everything on this diagonal is a 0, everything on this diagonal is a positive 1. What do you think everything on this diagonal is going to be? Positive 2. And so if this is 1, just make sure 2 is a little steeper. And guess what's on this diagonal? 3. So a little steeper. And then this is 4, and this gets really hard to, it's like you gotta think, okay, it's 1, and then it keeps getting steeper as you go along. Keeps getting steeper, right? You think, oh, this is -2, so this goes down a little steeper. This is -3, even steeper. -4, right, -5. All right? So far, so good. Now, let's deal with our ping pong ball. They give us an initial condition. They basically say, you got to dot at 0, 1. Right? So let's find out how the ping pong ball gets blown. As I go to the right, what happens to the ping pong ball?
It goes down. Roll.
As I go to the right,
Oh, from the point.
if I go from the point, as I go to the right, what happens?
Goes up.
Goes up. Everybody see it goes up? And so this goes up. As I go to the left, what happens?
It goes up again.
It goes up again. But you see all these flat spots? Because of all those flat spots, this is going to go down. It's going to level off. And this is kind of weird, right? Do you see these? If I did a better job drawing this, you see how these are all like a line? Whenever you see all these lines, it actually creates like an asymptote, like a wall. So what ends up happening as this blows, this is going to go up this way. And so this is your solution. Now, this part's interesting. See, this is a way more interesting graph, way more interesting function than the previous one. Because, like in the previous example, pretty much no matter where you started, the shape of the graph is basically the same. But in this one, like so here I gave you an initial condition of 0, 1. You know, what if I'd given you an initial condition of 1, 0? Actually, no, that would be a bad one. How about I do 2, 0?
Well, 2, 0 would be.
Oh, whoa. -2, 0, sorry. If I'm on this half. So if I pick a thing here, then this is saying, oh, wait. So with this one, it says, okay, we're going down, and then we're doing this. Do you see how we get a different graph?
Yeah.
You get a completely different shape depending on where you start. And that's fairly typical with these slope fields, is that you get a different graph depending on, I mean, this is a more interesting slope field. Right? All right. Okay, now this is a more reasonable, this is definitely more reasonable to construct a slope field. Right? So, everybody do that. In this one, construct your slope field. And here, this one is small enough. Okay, so at this one, I'm going to pick 0, 0, 0, 1, 0, -1, -1, 0, -1, 1, -1, -1, and what's that? 1, 0, 1, 1, and 1, -1. And I'm going to plug 0 in. That's going to give me -1. When I plug this in, I get a 0. Plug this in, I get a 0. Plug this in, I get a 0. Let's see, I think I get a 1. I get a 1. I get a 0. I get a 1. And I get a 1. Oh, yay, right? So at 0, 0, I'm at -1. At 0, 1, I'm at 0. Actually, I think all of those give me 0. And then I think everything else gives me a 1, doesn't it?
Yeah, 1.
1.
1.
right, of 1. Everybody okay with that?
Mm.
Now, here's the problem. Great, we constructed a slope field. Problem is there's not enough slopes to actually figure out what a graph looks like, because this is kind of weird, isn't it?
Doesn't make any sense.
Right, because there's not enough. Well, and I wanted you to practice, okay, here's how you can draw a reasonable slope field. But if we want to figure out exactly what's going on, we need way more dots, okay? And so our way more dots look like this. Right? And if you could look, you can still see, oh yeah, there's the 0, -1, there's the 1s, right? But since I have more slopes, I can figure out what's going on. And in particular, they're giving us these initial conditions. So they're saying, like, what happens at the point 0, -2? So if I plot the point 0, -2, right, oh, that's here. What kind of shape do we get? And can you see the, if this is 0, -2, let's see how the slope, how the wind blows it. And it says, well, okay, so it looks like it's doing this. It wraps around here. It starts curving up. And then it goes back down. And if you plot -1, oh, well, look, it's a little flat before it starts curving up. It's a little flat before it starts curving down, right? Now it's a little more interesting at 0, 0. Because then it starts here, it goes down before it starts curving up. Then it does this mess. There. And just so you know, I don't know how to solve that. Like, I don't know how to get y equals out of this. Maybe at some point in my career, I knew how to do it. They have a whole course that you take called differential equations, which they give you differential equations, they give you different tricks on how to solve them. We don't do that. Okay. Right. Now, this is this is typical of questions they ask on multiple choice on the AP exam. Sometimes they'll give you a slope field, right? And they'll ask you to they'll ask one of two things. Typically they say match the differential equation, or sometimes they'll say, well, what's the actual answer? Right? And in this case they're saying match a slope field with the general solution, right? Meaning, put a ping pong ball somewhere, see the path that the ping pong ball does, and which function does it match. So for this one, I'm going to put a ping pong ball, I'm just going to put it here, and if I were to guess where this thing goes, what does this graph look like? Sine. So we guessed what the solution was. Right? The same thing over here, if I put a ping pong ball here, what does this one match?
Oh, x cubed?
X cubed, which is the only one here that has an x cubed.
D.
Does everybody see how we can match this? Here's the slope field. How do we match the answer? Maybe they ask that more. Typically, what they do. Here, I want to do this. This is a more typical question. They give you a slope field and they ask you to match the differential equation. Right? And this can be an incredibly easy question, right? If you look at it the right way. But if you don't look at it the right way, it could be intimidating. Right? So what do you do? Right? How do you match? Right? Here's a slope field, here's our differential equations, how do we match? Well, the secret to this, right? The secret of matching slope fields to differential equations is, where is the slope 0? So in part A, where is the slope 0?
At 2.
At what is 2?
Y equals
At y equals 2. Does everybody see that? So which of the choices, here I'll scroll up, right? Which of these choices that every time you plug in y equals 2 gives you a slope of 0? You see this one? First, does everybody see at y equals 2 we have 0? And so you think, well, of all of these choices, when y equals 2, when do I get a 0? Like, when y equals 2, do I always get 0? And now that you think about it that way, is it obvious this has to be the answer? Because when y equals 2, you definitely get 0, right? And so this is choice 3. All right. Now let's look at this one. What gives you 0? Where are we 0 here?
At 0, 0. Or
No, well, what at 0? Well, what? I need a more general answer. You're right. At the origin, it's 0, 0. At the origin, the slope is 0. Where else is it 0?
the whole x equals 0.
Whenever x is 0, right? So wherever x is, so which one of these gives us a slope of 0? Which one of these differential equations gives us a slope of 0 when x is 0?
Number 2.
Oh, I do like that. Okay, you are right. It could be 2 or 4, right? And that is a very good guess based on what I've told you, right? It ends up being 4, and I'm going to talk about why in just a second, all right? Okay. So we've only seen slopes of 0 or 1 or -1 and like stuff. What causes a slope to be undefined?
0 over 0.
No, 0 on the bottom.
Oh, yeah.
Okay, so when anytime you get 0 in the bottom, you get a vertical slope, right? In this example, because we have in this differential equation, is it possible that you get an undefined slope?
Yeah.
Right? An undefined slope is vertical, right? Does this have any vertical slopes?
Mm-mm.
No. So it can't be this one, but we'll talk about when that happens. Right? But do you see how anytime you have a fraction, if the bottom can be 0, that means you're going to get vertical slopes in this. All right? Now, speaking of which, let's talk about this part. And I do apologize. This was created on a TI-84. And it's not obvious, so I'm going to make it obvious. These are 0 slopes, and these are vertical slopes. But when they drew up. So when I look at this, it looks like I have 0 slopes when x is 0, and I have vertical slopes when y is 0. Which one of these matches that? Do you see that I'm going to get a slope of 0 when x is 0?
Mm-hmm.
And I'm going to get a slope that's undefined, or a vertical slope, when y is 0?
Oh, yeah.
Okay, now let's look at this one. Although this is almost obvious, I think. Right? I mean, when you look at this, can you kind of see this as a trig function?
It's a sine.
It's either sine or cosine. And what's the only trig function we've got here?
Sine.
6. All right. Now, harder questions. Okay? And I've seen questions like this a lot. Here's the slope field, match it. Right? Where is it 0? Or can we identify these are the 0 slopes?
Yeah.
What's special about those? Like, what's the relationship between x and y there?
when both x and y are the same numbers.
When both x and y are the same number, right? 1, 1, 2, 2, 3, 3, 3, 4, right? So based on that, which one of these choices gives us a slope of 0 when x and y are the same number? Right? Do you see that?
Oh, yeah, yeah.
Okay. So that ends up being choice 5. And, well, the last one, just by process of elimination, it's got to be this one, right?
It's gotta be 1.
Yeah. and, yeah, that part. But, again, they're very typical questions. It's usually a multiple choice question, one way or the other. They either give you the slope field and they'll give you a choice where you have to pick the function, or they give you a function and they'll give you a choice of slope fields. All right, let's try it again. Here, let's go through A. Let's do it. Are there zeros? Where are there zero slopes?
At, like the diagonal.
No, give me coordinates. What's the relationship with x and y? What causes a zero slope?
When they're the same.
No.
Negative.
What's this coordinate?
1, -1.
Okay. What's this coordinate?
2, -2.
What's this coordinate?
-1, 1.
What's the relationship between x's and y's?
There's always a negative on the opposite one.
Which one of these matches it? Think about what this is saying. This says half of x minus 1. Does that give you 0? No. Right? Like these give me 0, right? Half of y, does that give you? No. If I do this over this, does that give me 0? But this last one says if I add the x and y values, do I get a 0?
Oh, yeah.
Do you see it?
Yeah, I do.
Okay. What gives you 0 here?
X equals 3.
X equals 2.
Oh, 2.
Okay. So at x equals 2, we get a 0.
Mm-hmm.
Which one of these, when x equals 2, gives you a 0?
Minus. Yeah.
You're getting better at it? Okay. It's a way of thinking, right? It's not hard, but someone's got to show you how to think about it. Because otherwise, I had to be shown, right? Okay. Okay, this is kind of mean. Maybe not. What gives you a slope of 0? Here's our slope of 0.
When y is 0.
Okay? So when y is 0, we get a slope of 0. Which one of these gives me a slope of 0 every time y is 0?
2.
2. And then the last one, notice we have slopes of 0 and slopes that are undefined. You can't see them because they didn't plot, right? So we need slopes of 0 when x is 0. We need slopes that are undefined when y is 0, right? It's got to be this.